Hey guys, this is Miss Garner, and this video will help you on the converse of the Pythagorean theorem Jamboard. This first slide is a review, and this is going over how to solve for the missing side of a right triangle using the Pythagorean theorem. So quickly, at the top here, I will write that theorem for you. Remember that it's a squared plus b squared equals c squared. And problem number one, the first thing you should notice is that we're given the two legs. So remember, if you draw arrows out from that right angle, those are your two legs. So we can call these A and B. Doesn't matter which one is A, doesn't matter which one is B. And the main thing to know here is we are solving for our hypotenuse. So the side that's opposite is what we're solving for. So we're solving for C. So anytime you are solving for your hypotenuse, remember that you are going to add. So this is going to be when we add our two squares together. So I will go ahead and do that. So you'll get 12 squared plus 5 squared. 12 times 12 is 144. And then 5 squared, which is 5 times 5, is 25. And remember, because we are solving for the hypotenuse, it is going to be adding these two together. So 144 plus 25. So when you do this, you get 169. And remember, this whole time, we are solving for c squared, or this whole time, this is c squared. But I don't care about c squared. What I want to figure out is what is c. I want to figure out the length c. So to get rid of that square, I'm going to take the square root. So your final answer should just be C. And then to get the square root of 169, remember this is just a calculator problem. So you're going to type it into your calculator and you get 13. So your final answer here is that C equals 13. On number 2, this time you will see that we're given one leg. So A can equals 15, but our other leg, the other side that would make that right angle, is missing. So we don't know what B is. So with these type of problems, they've given you the leg and they've also given you the hypotenuse. So in this case, the side opposite, this is C. They've given you the hypotenuse, they've given you one leg, and you have to solve for the other leg. So in this case, remember, we are going to subtract. So all of these steps are the exact same, except you're going to subtract. So we're going to take our bigger number, 21, do 21 squared, and subtract the smaller number, 15 squared. So in this case, we're just going to simplify now. So 21 squared is just 21 times 21. This equals 441 minus, and now I'm going to do 15 squared. So 15 times 15 gives you 225. Just a reminder, because we were given the hypotenuse and we're solving for the leg, we're going to subtract. So all the steps are the same, except you're going to subtract. So 441 minus 225, that equals 216. Same thing as last time. We have to take the square root as our final step. So we're going to take the square root of 216. So I'm going to open up that Web 2.0 calculator. And remember, the square root is that one that has a check mark there. It looks like a check mark with an X. So the square root of 216 equals, you see it's this big long decimal. Remember, you can stop after the thousands place. So after 3 numbers after the decimal. So 14.698. Or sorry, 14.696. And remember, we are solving for the leg, so this is actually going to equal B. So this is a quick review over Pythagorean theorem. The first problem, we are solving for the hypotenuse, so we add. The second problem, we are solving for a leg, so we subtract. So notice that the only place where these two problems differ is in this step right here, where it's adding versus subtracting. Everything else is the exact same. What we're working on now is the converse of the Pythagorean theorem. And when you hear converse, you should just think that we're going the opposite direction. So previously we said that if a triangle is a right triangle, then we can say that a squared plus b squared equals c squared. In all the problems we've seen, we're given a right triangle and we use the theorem to help us solve the missing side. This week, though, we're going to go opposite direction. We're going to say if a squared plus b squared equals c squared, then we know that it's a right triangle. So you can see how these two statements have just been reversed. So the way we're going to use these problems, or the way we're going to use the converse to solve problems, is to classify our triangles as either right, acute, or obtuse. So remember, a right triangle has a 90-degree angle. So that angle usually has a box in the corner. It looks like a sharp corner. Acute means that all the angles are less than 90 degrees. So the easy way to remember this is acute things are usually small and tiny. So these angles are small. And then an obtuse triangle, where the angle is greater than 90 degrees. So those are our three options. We want to say if the triangle is right, acute, or obtuse. The big thing to remember when solving these types of problems is that C is always the longest side. This is because C, remember, is your hypotenuse. That is always the longest side of your triangle. So on example 1 here, you will see that it is asking us to classify the triangle as either right, acute, or obtuse. I'm going to put this part here in yellow. This is the key. So this key you never have to memorize. It will always be given to you. And what we're trying to do is we're trying to figure out in our problem which of these three symbols will we have. It's going to be equal, less than, or greater than. So on my triangle, I first want to figure out which side is C. So remember, the biggest number is always C. So I know 13 has to be C. That means 5 and 12, it doesn't matter which one's which. One will be A, the other will be B. But the thing that really matters is that the biggest number is C. So what we're going to do now is we're going to say C squared. And I'm going to put a big box in the middle, because that box is going to be what we're trying to figure out. What symbol is going to go in that box? Is it going to be equal, greater than, or less than? So how does C squared compare to A squared plus B squared? Now I'm just going to plug in my numbers. So C squared is going to be 13 squared. So I'm going to get 13 times 13. That equals 169. I have that box in the middle. I'm trying to figure out what symbol to put there. And then A squared plus B squared, I get 5 squared plus 12 squared. So 5 squared is 5 times 5, so 25. 12 squared is 12 times 12, which is 144. I'm going to add those two things together. So 25 plus 144 gives me 169. Now that I've done this, I need to figure out what symbol to put in that box. Is it an equal, a less than, or a greater than? Obviously, these two numbers are the exact same, so I know that has to be an equal sign in between. So once I figure out what symbol goes in that box, I can look in my table and see which of these three cases do I have. I have the first one, right? I have an equal sign. So if I have an equal sign, I see that that means I have a right triangle. So my final answer, what kind of triangle is this? My answer is going to be that this is a right triangle. Okay, so your final answer is always going to either be right, acute, or obtuse. You're trying to figure out what type of triangle do we have. Because we figured out that that equal sign goes in the box there, I look in my table at that top row and I see that that means it's a right triangle. For example 2, I see I have the same question. It says to classify the triangle as either right, acute, or obtuse. Once again, they have given me this key, right? That key you will always have. You never have to memorize this. But you will see that this problem, instead of a picture, they have actually given us a description. So same thing though, you're going to figure out which side is C and go from there. So the biggest number is always going to have to be C. And then the other two numbers, it doesn't really matter. One of them is going to be A, the other one has to be B. All right, so once again, we're going to go ahead and compare those. So I'm going to say, how does C squared compare? I'm going to leave that box empty. What symbol is going to go there compared to A squared plus B squared? Okay, so I'm going to go ahead and plug in my numbers. 7 is C, so 7 squared, which is just 7 times 7 gives you 49. A squared plus B squared will be 4 squared plus 6 squared. So 4 times 4 gives you 16. 6 times 6 gives you 36. If I add those two things together, 16 plus 36, that gives me 52. So now that I have those two numbers, I can compare 49 and 52. What I know is that 49 is smaller, right? 49 is less than 52. So remember, the way our symbol works is if you imagine it as like a mouth or a crocodile mouth, it's wanting to eat the bigger one. So that's how I like to think of it. Think of this as having like teeth in there. It's a crocodile. It wants more food, so it's going to eat the bigger one. So that symbol looks like that. That's what we call, it's opening up towards the 52. So if we look in our table, we see that that corresponds to this middle row. C squared is less than A squared plus B squared. So that means we have an acute triangle. So my final answer is that this is an acute triangle. All right, so the main goal is figure out which of your three numbers is C, and you're going to compare C squared and A squared plus B squared. You can then look in your table to see which symbol that you are using to figure out what type of triangle that you have. And that is the converse of the Pythagorean theorem.